A very good afternoon to all. I, Kavyashi S., Assistant Professor, Department of Information Science and Engineering, VVC, Mysuru, extend a warm welcome for the Day 4 session on Internet of Things and its application. I take this opportunity to introduce our today's resource person, Dr. Reshma Banu. She has 19 years of teaching and research experience and is currently working as a head of the Department Information Science and Engineering, GSSSIETW Institute of Engineering and Technology for Women, Mysuru. She has published nearly 40 research papers in various national and international conferences and also various book chapters. She won the Best HoD of the Year by the CSI. She also won the Best Project Award at KSCST IEEE Bangalore section, also awarded with Best Paper Award at CSI national level. She also received funds by the Vision Group of Science and Technology under the scheme Seed Money to the Young Scientists. She is also a senior member of various committees like ISTE, CSTA, CSI, and SDIWC. We are very glad to have you, ma'am. Over to you.
Yeah, thank you so much for the introduction. I would like to state my heartfelt regards to HoD Dr. Rajendra sir for giving me an opportunity to be a part of your series of lectures related to IoT as per the VTU syllabus. And at the outset, it is my duty if I won't like express my regards to the institution where I am working. A heartfelt thank to the management and the principal of GSSSIETW for promoting me and providing the free slot from 3 to 4 for my live session. I thank our principal, Dr. M. Shivakumar, for providing me an opportunity to go for the live session. Thank you so much, sir. Yeah, without much further ado, can I start the presentation now? So my topic of today's discussion is data analytics for IoT. Data analytics for IoT is right now is a technology buzzword. Why? Because each and every company is adopting IoT technologies. Now, what is new in data analytics? Why actually data analytics is needed for IoT? Throughout my deliverables, I'm just going to discuss it. In a nutshell, I would just like to present what actually I'm going to cover in this 1 hour session. So first, I'll be dealing with introduction of data analytics, then the types of analysis results and all. Before that, I am going to tell a small story of all my discussion session. Now, why actually data analytics is needed? Data analytics is needed in order to retrieve useful patterns which are very much relevant to the applications. So what are these useful patterns? Why data is not having any useful patterns? Definitely data is nothing but it is some information. So that information which is useful for me, I'm going to retrieve in that way. So that is called the patterns which are very much relevant to my application. So IoT systems are producing vast volumes of data, far more than ever been available in the past. So this new type of continual data generation from all forms of connected network instruments has created an opportunity to gain new insights and improved efficiencies like never before, in a sense that the business value of IoT is not just the ability to connect the devices, but it comes from understanding the data these devices will create. A new form of data management then came into picture that is called as IoT data analytics. So now, data analysis is very, very important in any of the business organization in order to understand the problems facing being faced by the organization, and to explore data in the meaningful ways. Data itself is merely the facts and figures. The data analysis will organize, interpret, structures, and presents the data into the useful information that provides the context of the data. So now the question is how IoT analytics will benefit the business organization. This is a main thing why actually IoT data analytics came into picture. Why? Because most of the business organizations are adopting IoT technologies. Why they are adopting IoT technologies? Because that the firms are very big. So many, the branches of a companies will be there, and they want to have the data of all the firms at one single stretch. So in that concern, they prefer going for data analytics tools. So the main importance of analytics that benefits business organization is that it will identify the inefficiencies, it will improve productivity, it will boost the revenue. Business organizations are mainly running for a profit margin only. So in order to boost the revenues, what are the cons, what are the pros for the business loss? So all those things they will get to know when they analyze the data. So implementing IoT technologies will allow the the entrepreneurs or the higher ups of the organization to turn the big data that gathered in order to increase the revenue. So IoT is predictive, it will predict the future. So better understanding of the customers, customer engagement, everything can be dealt by analyzing the data. So Internet of Things refers to analyzing and examining the data obtained by the Internet of Things. That means the sensors, the network end devices, data storing and transmitting equipments that are the key components of collection of Internet of Things data upon which the analysis need to be done. Why analysis has to be done? That is why I have discussed analysis should be done in order to identify the inefficiencies of our business firm, to improve the productivity and to boost the revenues. Now we have two types of data. I can say that most of the data from IoT is unstructured. So now what is this structured and unstructured data? You may be knowing in IoT, millions and trillions of devices are part of IoT network. In a sense that if I connect a pen, it will become a smart pen to the IoT. If I connect a device, it will become smart. So this is likewise each and every device which is a part of IoT will become a smart object. These smart objects are connected to IoT networks in order to transmit and receive the data. So when I say millions and trillions of devices are connected to the internet IoT network, so much of data will be gathered. So when IoT networks are very useful in a sense that they will provide insights to the business, they will give meaningful to the data that is available. If it is not structured, then it is of no use. Why? Because structured data will consume, technically if I want to speak, it will occupy less memory space, and then it will be a structured one, and easily you can access the data whichever is need of the hour very easily. If the data is not stuck in a structured way, then definitely it will consume lot more of energy, memory space, and then relevant of the information what you want to retrieve will be a Hercules task. So structured data, best examples are the spreadsheets and the databases. And unstructured data, as you can see, the text, the images, the video, the speech, all these comes under the unstructured data. So one thing is clear that IoT data is most means 80% of the data that has been generated by IoT is unstructured one. So structured data is that which allows the data to follow certain module or a schema that defines how the data is represented or organized. In a sense that it will fit well with the traditional relational database management system. Whereas unstructured data lacks a logical schema for understanding, decoding the data through traditional programming means. Examples of this data already I have told. It is the form of text, speech, images, and then the video. any data that does not fit correctly into the predefined data model, it can be classified as a unstructured data. So in a very simple way, 80% of the IoT data will be unstructured. So you can see here the organized formatting. Why? Because the picture speaks better than the explanation. So my slides are mostly diagram oriented. So the types of data analysis results. Next, we are coming towards the topic, that is data analysis. Here you can see 4 types of data analytics. One is descriptive, another one is diagnostic, predictive, and then perspective. What is this data analysis? Types of data analysis. Now, if a data, IoT data, the real value of IoT data, in a sense, if the data means to be something valuable for an organization, then actually it should lead to actionable business intelligence or to the insight. That means some decisions need to be derived from the data that is available from IoT devices. This is what is actually the real value data of IoT. How actually the real value to IoT data becomes. So this is with the application of data analysis techniques and tools that make actually the IoT data more meaningful for the organization. Meaningful in a sense that with that derived data analysis results, the company can reveal the pros and cons of the decision taken. They can predict better decisions in the near future to come. They can come to know what are the failure factors for the current scenario. So many n number of attributes can be dealt only if and only if the data leads to actionable business intelligence or insights. Based upon that, depending upon the result that the data analysis provide, there are 4 different types of data analysis. So these things have been depicted here. True importance, that is what I told, true importance of IoT data from the smart objects is realized only when analysis of the data leads to actionable business intelligence and insights. The data analysis is typically broken down by the types of results that are produced. So the diagram represents data of different types that will be forwarded to big data technologies. That is, let us say Apache Hadoop, what is that Apache Hadoop? It is a big data technology wherein it is a Java-based free software framework that can effectively store large amount of data in a cluster. Then we have the Microsoft HoD inside, which is nothing but it is a big data solution from Microsoft, powered by Apache Hadoop, which is available as a service in the cloud. We have other big data technologies, so to say, NoSQL, Hive, Scoop, and then Polybase. Now, coming to the very first type of data analysis, that is descriptive analysis, it will answer what has happened, in a sense that it deals with the data aggregation, the summary, and the data mining. Diagnostic analytics will reveal why did it happen. That means if some decision has been taken at the business organization, and this descriptive will say what is happening. Diagnostic data analysis will put a light towards why did it happen, and the predictive will say what might happen, such as regression. Prescriptive analytics is much more oriented towards what should I do about it. If something has happened, some decisions the decision makers have taken, it may lead to the loss or it may lead to the profit. So prescriptive will say what should I do about it. If something good has happened, okay, fine. If something that is not up to the mark has happened according to the expectation of the higher levels of the organization, then definitely what should I do about it? These questions should be dealt with. So how actually, what is happening? Why did it happen? What is likely to happen? What should I do about it? So all these questions Answers will be available only when the data will be analyzed in a proper way. That is the main reason why IoT data need to be analyzed. So, descriptive analytics on IoT data focuses on what is happening by monitoring the status of IoT devices, machines, the products, and the assets. It determines if things are going as planned and notifies if anomalies occur. Descriptive analysis is generally implemented as dashboards that show current and historical sensor data, key performance indicators, statics, and then alerts. Now, coming to diagnostic analysis on IoT data, which will concentrate towards why did it happen, it will answer the question, why is something happening? Analyzes IoT data to identify core problems and to fix or improve a service, product, or a process. Diagnostic capabilities are typically the extensions of dashboards that permit users to drill into the data, compare it, they will visualize correlations and trends in an ad hoc manner. Many organizations employ domain experts knowledgeable about a specific process, the machine, the device, or a product, rather than the data scientists to perform the diagnostics on the data. Now, predictive analytics on IoT data. What it will do? The predictive, what is likely to happen? It raises the question, what will happen? Assesses the likelihood that something will happen within a specific time frame according to historical data. The aim is to proactively take corrective actions before an undesired outcome occurs, to migrate the risk or to isolate the opportunity. Every business organization are very much eager to see the loss rather than very much eager to have the profit rather than the loss. So this predictive analytics will help them to take towards better decisions. Typically implemented, it will be done with the help of machine learning models that are trained with historical data and stationed on the cloud so that they can be accessed by end user applications. Now, coming to prescriptive analytics on IoT data. So, this prescriptive analytics on IoT data, it will poses the questions like, what action should I take? It suggests the actions based on the results of the prediction or diagnosis, or provides some visibility to the prediction or diagnostic. Recommendations tend to be about how to optimize or fix something, that kind of questions it will answers. Now, what are the challenges? Is data analytics is so very easy task? Is it having a very positive phase of analysis? Definitely not. It is like the faces of a coin. If something is advantageous, the other face will reflect the disadvantages also. I may not term it as a disadvantage, but there are some challenges that has been put forth by IoT analytics. What are those challenges? Let us see. So the very first challenge is scaling problem. Second important challenge is volatility of data. Scaling problems, from where does it come from? Due to the large number of smart objects, just remember the term IoT is a collection of millions and trillions of devices receiving and transmitting the data. In a very simple definition, I can term that. So once they are into the network, they become a smart object. Okay, so for no reason they can be they can be a part of IoT network. The reason behind they are part of the IoT network is that they are willing to transmit and receive the data. Right. So due to the large number of smart objects in most IoT networks that continuously send the data, the relational databases can grow incredibly large very quickly. So this is one of the major challenges that has to be dealt in IoT data analytics, because the data simultaneously will be transmitted and received from multiple devices. Let me say millions and trillions of devices connected across the IoT networks. Then obviously the relational database memory size will grow very quickly. So this has to be noted. Next thing is that the volatility of the data. What do you mean by volatility of the data? In a sense that um, this relational databases, it is critical that the schema can be designed correctly from the beginning. Changing it later can slow or stop the database from operating. Volatility of a data in a sense that the data is not it is not constant. It is growing, keep growing. Okay, so machine learning has been introduced in order to find a solution to all these challenges that has been posed by IoT data analytics. So how actually the machine learning will yield a better result for IoT data analytics challenges? Let us see. One of the core subjects in IoT is how to make sense of the data that is generated. This is one of the major challenge. So ML is indeed central to the IoT in a sense that data collected by smart objects need to be analyzed and intelligent actions need to be taken based on these analysis. So machine learning is a part of larger set of technologies commonly grouped under the term artificial intelligence. So ML is a vast field as each and everyone knows now, but it can be simply divided into two main categories. One is supervised learning, another one is unsupervised learning. So what is this supervised and unsupervised learning? Supervised learning in a sense that it learns from label training data. The supervised learning algorithm learns from label training data. It helps one to predict the outcomes for unforeseen data. It successfully building, scaling, and deploying accurate supervised machine learning. The data science model takes time actually and technical expertise from a team of highly skilled data scientists. Moreover, the data science which are involved into supervised learning must rebuild the models in order to make sure the insights given remains true until its data changes. So in supervised learning, the machine is trained. In simple words, I can say, in supervised learning, the machine is trained with input for which there is known correct answer. Hundreds or thousands of images are fed into the machine. This is called a training set. Best example for this one is determining whether the shape is a human or something else, such as something else in the sense that whether the shape is relevant to the human or to the vehicle or the pile of a wood or rock or etc. So unsupervised learning in a sense that it will be it is also a machine learning technique where you do not need to supervise the model actually. Instead, you need to allow the model to work on its own to discover the information. It mainly deals with the unlabeled data only. In machine learning, we have the classification, regression, and clustering. So unsupervised learning, the best example is the aircraft fall detection. In machine learning, classification refers to predictive modeling problems where a class label is predicted for a given example of input data. Examples of classification problems include to detect whether classify if there is a spam or not. Given a handwritten character, classify it as one of the known characters, something like that. Regression models are used to predict a continuous value, predicting prices of example, that is the predicting prices of a house given the features of a house, the features of the house is the area, the size, the prices, etc., is one of the common examples of regression. So it will come under supervised learning. Next thing is why supervised learning is so very important. Supervised learning allows you to collect the data or produce a data output from various experiences. For example, it helps you to optimize performance criteria using the experience, or supervised machine learning helps you to solve various types of real world computation problems. So why then? What is the importance of unsupervised learning? Why we need supervised learning? We understood, and why unsupervised we want. Here are the prime reasons for using unsupervised learning. What are those prime reasons? why unsupervised learning will be needed. So unsupervised machine learning finds all kind of unknown patterns in data. Unsupervised methods helps one to find features which can be useful for the organization. It is taken place in real time, so all the input data to be analyzed and labeled in the presence of the learners. Then one important thing about unsupervised learning is that it is easier to get unlabeled data from a computer than a labeled data. Some data you are having, you forgot to rename a file name, so it becomes unlabeled data. So in a sense that the unsupervised learning, it is easier to get the unlabeled data from a computer than a labeled data, which needs a manual intervention. So next we are going to deal with the neural networks. What is this neural network? A neural network, everyone knows, is a series of algorithms that endeavors to recognize underlying relationships in a set of data through the process that mimics the way the human brain operates. So, mimicking the human brain. In this sense, neural networks refers to systems of neurons, either organic or artificial in nature. So neural networks can adapt to changing inputs such as, so the network generates the best possible results without needing to redesign the output criteria. The concept of neural networks, actually it comes from artificial intelligence, and it's gained its popularity in trading systems. Neural networks are broadly used with the applications for financial operations, then enterprise planning, trading, business analytics, and product maintenance. Neural networks have also gained widespread adoption in business applications such as forecasting, marketing research solutions, fraud detections, and then risk management. So, neural networks are machine learning methods that will mimic the way the human brain works. When you look at a human figure, multiple zones of your brain are activated in order to recognize the color, the movement, the facial expressions, and so and so and so on. So the brain combines these elements to conclude that shape you are seeing is human or not. Neural networks will mimic the same way, the same logic. The information goes through different algorithms. That algorithms, we say it as this units. We say it is called as units. Each of which is in charge of processing an aspect of information. So, in a textbook, one problem has been given, how neural networks recognize a dog in a photo. So, first the training should be given. During the training phase, a neural network is fed thousands of labeled images of various animals, learning animals, learning to classify them. Then the input will be an unlabeled image that is shown to the pertained network. After that, the neurons will respond to different simple shapes like edges. After this stage, the neurons will be more complex in structure. So later, the neurons respond to highly complex abstract concepts that identify as different animals. So finally, the output after training this much of levels, the neuron predicts what the object mostly likely is to be. After training, based upon the training, it will predict whether the snapshot which has been which it is intended to recognize is a dog in a photo or not. Okay, if this is about the neural network. Next comes a very important and a catchy topic that is called Hadoop. Everyone knows Hadoop. Let us go through the fundamental concepts related to Hadoop. Let me say I am having a file. File means the data of a it is a voluminous data. I finished writing I want to store that content of a file to a system. I started a process, I stored the data into my machine, and after that, the capacity of the memory is not available. Then I will split that main file. Some part of the data I'm going to load to some other system. It is also not supporting. Memory is not there. So that is why remaining contents of the data I am going to store in another system. So totally 3 systems I have used in order to store the contents of a single file. Why am I taking 3 machines? Why? Because my file is having voluminous data which is beyond the storage capacity of a particular system. So how do I manage? Why? Because I'm having a single file. The content I have stored in 3 different files. So this file system, this large voluminous data will becomes meaningful with the advent of big data analytics. So under big data, we are going to study Hadoop distributed file system. So this Hadoop is an open source software platform for scalable distributed computing. Hadoop provides a fast and reliable analysis of both whether the data is structured or unstructured, but it will give fast and reliable analysis of that particular data. In my previous slide, I have discussed that structured data is more easy to retrieve. Structured data will consume less memory as compared to the unstructured data. Definitely, these limitations will be there. But beyond this, the Hadoop is such an open source platform. Knowing the requirements of a business organization and the type of a data, it is particularly designed for scalable and distributed computing. Okay, so this Hadoop provides it is whether it is a structured or unstructured data, it is least bothered, but rather it will provide fast access and reliable analysis for both kinds of data. So Apache Hadoop software library is essentially, it is a framework which will allow the distributed processing of large data set across the clusters of computers using a simple programming model. In a sense that it is used to effectively or efficiently store and process large data sets. In simple way, if I want to explain what is Apache Hadoop, I can say that Apache Hadoop is an open source framework that is used to effectively store and process, not only store and to process large data sets ranging in size from gigabytes to petabytes of data. Instead of using one large computer to store and process the data, Hadoop allows clustering of multiple computers to analyze massive data sets in parallel more quickly. This is the summary of the slides what I am presenting. That is why I gave an example of a voluminous file wherein I am dividing the contents of that file into 3 machines. Why? Because the memory of that particular machine is not supportive to such a voluminous data. So we can conclude that it allows the Hadoop, instead of using one large computer to store and process the data, it will allow the clustering of multiple computers to analyze massive data sets in parallel more quickly. So what are the we have two important key elements which makes Hadoop so supportive. What are those key elements? One is Hadoop distributed file system. Another one is MapReduce. This Hadoop distributed file system is nothing but a system for storing the data across multiple nodes. MapReduce, on the other hand, it is a distributed processing engine. It will reduce or splits the large tasks into smaller ones that can be run in a parallel way for a better performance and easy retrieval. Why Hadoop is booming? Why? Because if you see the slide starting from the year 2007 till 2020, the number of companies adopting Hadoop is incredibly varying. That means it is incredibly more. This is the publicity, or why? Because it is user friendly and it is meeting the requirements of the business enterprises. That is the reason the Hadoop adoption in industry is scaling day by day. If you see from 2007 till 2020, the adoption in industry is increasing because of its feature. What are those features? It provides fast and reliable analysis of both structured and unstructured data. And actually, this Hadoop was originated as a result of the projects at Google and Yahoo. And the original intent for Hadoop was to index millions of websites and quickly return search results for open source search engines. So, as a byproduct of projects at Google and Yahoo, Hadoop was originated, and it has been largely deployed by most of the industries starting from the year 2007 till 2020. Now I told there are two important key ingredients of Hadoop. One is Hadoop distributed file system, another one is MapReduce. Now what is this Hadoop distributed system? Hadoop distributed file system is a distributed file system that provides high throughput access to the application data, and it uses the master slave architecture in which one device will be a master. This is termed as a name node always, and this name node controls one or more devices. Those devices are termed as the slaves. The slaves are data node. I can summarize that distributed file system, HDFS is a distributed file system. It provides high throughput access to the application data. It will run on a master slave architecture where the master will be the name node and the multiple data nodes will be the slave nodes. So it breaks data or the files into smaller blocks varying from 128 MB, or each block is of 128 MB only, and it stores on data node, and each block replicates other nodes for the fault tolerance. So name node keeps track of the blocks returned to the data node. Why? Because name node is a master. Under that, multiple data nodes will be there. So what and all the data or the blocks, we won't say the data, actually we say the data block. Whichever blocks have been returned to the data node, that will be controlled by the name node. It will keep track of the data that block that has been returned to the data nodes. So, how actually a block will be written to HDFS? Hadoop distributed file system is one that runs on a standard or low-end hardware first. Let us understand some of the fundamental things about the Hadoop distributed file systems before going into this particular slide. HDFS provides better data throughput than the traditional file system. Some of the important key points, so why the it is so very being adoptable by industries. What are the factors, key ingredients which is making Hadoop to be adopted by most of the IT industries is that it provides better data throughput comparative to traditional file systems, in addition to high fault tolerance and native support of large data sets. It has got Hadoop is also having one more module that is called yet another resource negotiator. So we say it as YARN, YARN. So in the next slide, we will be dealing in detail. So this YARN manages and monitors cluster nodes and resource usages. It schedules the job and task. That is a major part of YARN. And MapReduce is one of the important part of Hadoop. A framework, how can you define the MapReduce? I told you it will divide the larger files into the smaller one, and for the faster processing it will be done. In the more technically speaking, MapReduce, we can say that it is a framework that helps programs do the parallel computation on the data. When you do the parallel computation on the data, then definitely it will speed up the efficiency and the throughput. The map task takes input data and it will convert it into the data set that can be computed in a key value pairs. So this output of the map task is consumed by reduce tasks in order to aggregate the output and provide the desired results. The next module of HDFS is Hadoop Common. It provides common Java libraries that can be used across all the modules. So now, going in detail with the Hadoop architecture, whatever writing the files to HDFS, a large file that can be stored in one machine. For a large file, if you want to store it in one machine, one simple solution will be there. What is that solution? It would be to store the data across a network of the machine. Such file systems, we say it as distributed file system. Since this data stored across a network all the complications of networks comes in now. In a sense, this is where Hadoop comes in. Are you following? Hope I am clear. So this is where the role of Hadoop comes in. It provides one of the most reliable file systems. So this Hadoop distributed file system is uniquely designed such a way that it provides storage for extremely large files with streaming data access pattern, and it runs on commodity hardware, you can say. So let us elaborate the terms that have been used in Hadoop. Extremely large file. What does it mean in Hadoop? Extremely large file. So it can compensate and it can store the extremely large file. Extremely large file in a sense that the data in the range of petabytes. We are talking about the data. Large file in a sense that we are talking about extremely large file means it is in terms of data. Like how many bytes it will be? It will be in terms of petabytes, that is 1000 TB. Streaming data access pattern. Streaming data access pattern means what? What actually, how HDFS deal with streaming data access pattern? HDFS is designed on a principle of write once and read many times. Please remember, so HDFS is designed on a principle of write once and read many times. Okay, so once data is written, large portion of data set can be processed any number of times. Commodity hardware is one of the key terms that is always associated with Hadoop. It means that the hardware, why am I elaborating these terminologies is that in my future slides, I am going to talk about these terminologies. So before that, I'm going to brief out about these terminologies. Like the commodity hardware in a sense that it is a hardware that is inexpensive and easily available in the market. This is one of the feature which specifically distinguishes HDFS from other file system. So we have already gone through in the previous slide that Hadoop distributed file system will operate in a master slave manner. It will be having a master node, name node is a master node, and then the data node as a slave node, wherein the master node as a name depicts is a general common English, wherein the master will keep track of the control of the slaves. The same way all the blocks that has been written into the data node will be monitored and kept track by the master node that is called the name node. So this master node manages all the slave nodes and assign work to them. It will assign work to the data nodes. It executes the file system namespace operations like opening, closing of the file, renaming of the files, and the directories also. It should be deployed on reliable hardware which has high configuration, not on a commodity hardware definitely. So this name node actually works, we can say name node as a worker node. Who do the actual work like reading, writing, and processing. It also perform creation, deletion, and replication upon the instruction from the master node. They can be deployed on a commodity hardware also. So the client calls the create method on distributed file system to create a file. After that, the distributed file system interacts with the name node through the remote RPC call to create a new file in the file system namespace with no blocks associated with it. After next step is the name node will checks for the client privileges and make sure that the file doesn't already exist. If the client has sufficient privileges and no file with the same name exists, the name node makes a record of the new file. Otherwise, the client receives an input-output exception and file creation will be failed. The distributed file system then returns the data output stream for the client to where the client starts writing the data. So the FS data output stream in turn wraps the DFSO output stream which handles communication with data nodes and the name node. Now, as the client starts writing the data, the DFS output stream splits the client's data into packets. and writes it to an internal queue which is called the data queue. Data streamer, which is responsible for telling the name node to allocate new blocks by choosing the list of suitable data node to store the replicas, uses this data queue. After that, the list of data nodes forms a pipeline. The number of data nodes in the pipeline depends upon the replication factor. Definitely, suppose the replication factor is 3, then so there are it means that there are 3 nodes in a pipeline. So the data streamer streams the packet to the first data node in the pipeline, which stores each packet and forwards it to the second node in the pipeline. Similarly, the second data node stores the packet and transfer it to the next node in the pipeline, that is to the last node. What is the job of DFS, this output stream? It maintains another queue of packets. It is called acknowledgement queue, ACK queue, which is waiting for the acknowledgement from data nodes. The packet in the acknowledgement queue gets removed only when it receives an acknowledgement from all the data nodes in the pipeline. After that, the client calls the close function method. On the stream, when the writing of the file has done. Thus, before communicating the name node to the signal about the file complete, the client closes methods action pushes the remaining packets to the data node and waits for an acknowledgement. And this will be the next step. So the last step of writing the file to HDFS is that as the name node already knows about the blocks, that is the file made of, so the name node only waits for blocks to minimally replicate before returning successfully. So key pairing of Hadoop MapReduce will be given in the next slide. MapReduce is a software framework because it is one of the major components of Hadoop only. MapReduce is a software framework and programming model used for processing huge amounts of data. So this MapReduce program works in 2 phases. One is map and then it is reduce. It is there itself in the MapReduce. One is mapping and then reduce. Map task deals with splitting and mapping of data, while reduce tasks shuffle and reduce the data. Hadoop is capable of running MapReduce programs written in various languages like Java, Ruby, Python, C++. MapReduce programs are parallel in nature in a sense that they are very useful for performing large-scale data analysis using multiple machines in the cluster. So this is about the MapReduce. So it will map and then reduce. The input to each phase key is like it is a value pair. Key is equal to value pairs. In addition, every programmer needs to specify 2 functions. One is map function, another one is the reduce function. And the data goes through the following phases. Very first phase is the input split. Very first phase is the input split. So in this input split, an input to the MapReduce job is divided into fixed size pieces called the input splits. Input split is a chunk of input that is consumable by a single map. So this mapping, next step is mapping. So in mapping, very first phase in the execution of MapReduce program, mapping. In this phase, data in which split is passed to a mapping function to produce output values. So that will be concentrated. The job of mapping phase is to count the number of occurrences of each words from input splits. More details will be given in the next slide, and it prepares a list in the form of word frequency. One example has been given in the textbook in order to count the number of words in a sentence. So with that one, the MapReduce algorithm has been used, and it is very much self-explanatory. So I'm concentrating towards the key value pairing in Hadoop MapReduce. The very first step in MapReduce is the input will be split, and then the mapping, then shuffling. In shuffling, this phase consumes the output of mapping phase definitely, because it comes after the mapping phase. Its task is to consolidate the relevant records from mapping phase output. In the example that has been mentioned in the textbook, same words are clubbed together along with their respective frequency only. After mapping, shuffling, and then next step is reducing. In this phase, the output values from the shuffling phases are aggregated. This phase combines values from shuffling phase and returns a single output value. Even after it splits so many tasks, the output will be a single value. So in short, this phase summarizes the complete data set, we can say. So now, what are the limitations of this MapReduce? What are the limitations of this MapReduce? The limitations of this MapReduce have been pointed here as number one limitation is issue with small files. What is this issue with small files? The idea behind Hadoop was to have a small number of large files. Have a small number of large files, but if you have many small files, then Hadoop cannot manage it. Small files are those files whose size is quite less than the block size in Hadoop. Each file, the directory and the block occupies a memory element inside. Inside the name nodes memory only. As a rule of a thumb, this memory element is about it is about 150 bytes. So if you have 10 million files each using a block, then it would occupy 1.39 gigabyte of memory. Scaling beyond this level is not possible with current hardware. Also, retrieving small files is very inefficient in Hadoop. This is one of the limitations. That is why it has been cited as issue with the small files. At the back end, it causes many disks to seek and hopping, it is HOPPING, hopping from the one data node to another. So it incurs a lot of time to do that. That is why it has been titled as the limitation. That is, it is having issues with the small file. Then what will be a solution for this? The solution for this might be the Hadoop archives or HAR files will be having. It is one of the solution to to solve this issue with the small files. Hadoop archives acts as another layer of the file system over the Hadoop. With Hadoop archive, with this command, we can build HAR files. This command runs on MapReduce job also at the back end to pack the archive files into a small number of HDFS files. But again, reading through HAR files is not much efficient than reading through HDFS. This is because it requires to access two index files and then finally the data files also. The sequence file is another solution to small file problem. In order to overcome this problem, sequence file is another solution. In this, we write a program to merge a number of small files into one sequence file, and then we process this sequence file in a streaming fashion. MapReduce can break this sequence files into chunks and processes it in a parallel, as we can split the sequence file. The next limitation is slow processing speed. In Hadoop, the MapReduce reads and writes the data to and from the disk. This is very much common and known to everyone. In Hadoop, the MapReduce reads and writes the data to and from the disk. For every stage in processing, the data gets read from the disk and returned to the disk. This disk seeks takes time, thereby making the whole process very slow. Now, if Hadoop processes the data in small volume, it is very slow comparatively. It is ideal for large data sets, as Hadoop has batch processing engine at core. Its speed for real-time processing is less. Hadoop is slow in comparison with newer technologies like Spark and Flink that we are going to discuss. So, solution for this slow processing speed is the Spark. Spark is the solution for the slow processing speed of MapReduce. Hadoop, this one, the Spark is a solution to overcome the limitation of slow processing speed. With this one, it doesn't, what is that? It does in memory calculation, which makes it 100 times faster than Hadoop. The solution part I am saying, in order to overcome the limitation of slow processing speed, Spark is a solution for the slow processing speed. The Spark, while processing, it reads the data from the RAM and writes the data to the RAM, thereby making it fast processing tool. Flink is one more technology which is faster than Hadoop MapReduce as it does in memory calculation. So Flink is even faster than Spark. This is due to stream processing engine at the core as opposed to Spark, which has batch processing engine. Okay, so this Spark, Flink, which are have been evolved in order to overcome the limitations with the small files and slow processing speed. So, as and when we can say that no technology is complete, the pros and cons will be there forever. And this is a kind of analysis. If this technique has been launched, let us see the positive phase of it with comparatively to the present system. If the proposed system is very good, then go for that. And that proposed system is not also ultimate. It will be having also some limitations. So work on that. So it will be a continuous process, I can say. The solution for slow processing speed will be done with with an advent of new techniques like Spark and Flink. The other limitation is no real-time data processing. No real-time data processing in a sense that Hadoop with its core MapReduce framework is unable to process the real-time data. Hadoop processes the data in batches. That is very much clear by this time. First, the user loads the file into the HDFS. Then the user runs MapReduce job with the file as input. It follows the ETL cycle of processing. So the user extracts the data from the source, then the data gets transformed to meet the business requirements, and finally it will be loaded into the data warehouses. Fine. The users can generate insights from this data. The companies use these insights for the betterment of their business. What is the solution for this no real-time data processing? Yes, we have a Spark as a solution to overcome this no real-time data processing limitation. It has come up, the Spark has come up as a solution to the above problem, whatever I have mentioned with the no real-time data processing. The Spark supports the real-time processing. It processes the incoming streams of data by forming micro batches and then applying computations to these micro batches. Again, Flink is also one more solution for slow processing speed. It is even much faster than the Spark as it has because it has a stream processing engine at the core. The Flink is a true streaming engine with adjustable latency and also the throughput. It has a rich set of APIs exploring screaming runtime. Well, the next limitation will move on to the security. This security is Hadoop is challenging in managing complex application. Hadoop is challenging in managing the complex application. If to say if the user doesn't know how to enable a platform, who is managing the platform, your data can be at the huge risk. At storage and network levels, Hadoop is missing encryption. We can say, which is a major point of concern. So Hadoop supports Kerberos authentication, which is very hard to manage. HDFS supports HDFS supports access control list and also the traditional file permission model. However, the third-party vendors have enabled an organizations to leverage active dictionary Kerberos and LDAP for authentication. Now, moving towards Yarn, yet another resource negotiator. As I have told in the beginning, the major basic components of Hadoop are HDFS, Yarn. So, Yarn we are introducing as a next topic of discussion. It was introduced with the version 2.0 of the Hadoop and it was designed to enhance the functionality of the MapReduce only. With the initial release, MapReduce was responsible for batch data processing and job tracking. and resource management across the cluster. YAN was specifically developed to take over the resource negotiation, like job tracking, allowing MapReduce to be responsible only for data processing. In a sense that it is a software that rewrite. Is a software rewrite that is capable of decoupling MapReduce's resource management, and it also has a scheduling capabilities from the data processing component. So the Hadoop ecosystem is a platform or a suite, we can say, which provides various services to solve the big data problems. It includes Apache projects and various commercial tools and solutions. There are four major elements of Hadoop, that is HDFS. We have already, I'm just recalling it. Major elements of Hadoop: HDFS, MapReduce, YARN, and Hadoop in common. Hadoop common. Most of the tools or solutions are used to supplement or support these major elements. All these tools work collectively to provide services such as absorption, analysis, storage, and maintenance of the data. What I can say, there are a few components that collectively form a Hadoop ecosystem. What are the components that collectively make a Hadoop system are HDFS, that is Hadoop Distributed File System, yet another resource negotiator, that is YARN. MapReduce means programming based data processing, Spark in memory data processing. We have Hive, that is a query based processing of data services, so on. So Apache Kafka will be the next topic of discussion. So Apache Kafka is an open source stream processing software platform developed by the LinkedIn and donated to the Apache Software Foundation, written in Scala and Java language. The project aims to provide unified, high throughput, low latency platform for handling the real data time data feeds. Sorry, real time data feeds. So this Kafka consists of the records, the topics, the consumers, the producers, the brokers, the logs, the partitions, and the clusters also. So these records can have a key, a value, and a timestamp actually. This Kafka records are immutable. A Kafka topic is a stream of records, we can say. You can think of a topic as a feed name. A topic has a log, which is the topic storage on the disk, and topic log is broken up into the partitions and the segments. The Kafka producer API is used to produce streams of data records. And then the Kafka consumer API is used to consume a stream of records from Kafka. A broker is a Kafka server that runs in a Kafka cluster. Kafka brokers from a cluster. Kafka cluster consists of many Kafka brokers on many servers. The broker sometimes refers to more of a logical system or as a Kafka whole, as a whole. So next topic is Apache Spark. Actually, we have discussed this one as a solution to most of the limitations of Hadoop. So it is in-memory distributed data analytics platform that is designed to accelerate the process in the Hadoop ecosystem. And the in-memory characteristics of Spark is what enables it to run on jobs very quickly, fast processing only. So next topic of discussion is it is something like we are touching to some of the important topics that will speed up the processing of Hadoop and make it a useful tool for business enterprises. We have next thing is Apache Storm and Apache Flink. So both of them are Hadoop ecosystem projects only, and these are designed for distributed stream processing and are commonly deployed for IoT use cases. This is very, very important. And then this Storm can pull data from Kafka, and it can process it in a near real-time fashion, so that it is same as that of Apache Flink. And this space is rapidly evolving because it will continue to gain and lose popularity as one or the other technology comes into picture. Whichever is advantageous for one's application, that will be adopted. And now we are coming to the Lambda architecture. So this Lambda architecture basically used to handle large voluminous quantities of a data. That is why it is called as Lambda architecture. This architecture is specifically for IoT and big data. And some of the key terminologies that are used in Lambda architecture are the stream layer, the batch layer, and the serving layer. Hello. The Lambda architecture, as I told, it is architecture that has been designed to handle massive quantities of data. So it will take the advantage of both the batch processing and stream processing. What some terminologies also I have highlighted here. The stream layer. This layer is responsible for near real-time processing of the events, and the batch layer consists of batch processing engine and data store. Serving layer is already I have told. The serving layer is a data store and mediator that decides which of the inside layers to be viewed the data into or not. So edge streaming analytics. So I would like to just give important terminologies in detail which are relevant to Lambda architecture. The batch layer stores all the data with no consistent on schema. This schema on read is built in the batch views in the serving layer. Creating schema on read views requires algorithms to parse the data from the batch layer and it convert them into the readable way. So it allows input data to freely evolve as there is no constraint on their structure. But definitely, the algorithm that builds the view is responsible to manage the structural change in order to still deliver the same view as expected. So this shows coupling between the data and the algorithms used for serving the data. The speed layer handles the data that are not already delivered in the batch, but because of the latency of the batch layer, it handles most recent data in order to provide a complete view of the data to the user by creating real-time views. The combination of the batch views and real-time views allows the user to get up to data information from the system. So that's a good point for the data quality dimensions called data freshness and availability. But this architecture implies the use of some probabilistic algorithms when then the accuracy dimension is undetermined so as to get a better availability. Next topic of discussion is edge streaming analytic. So this edge streaming analytic is a powerful cloud-based tool for creating stream processing workflows that can be deployed to edge devices. It helps manufacturers and industrial companies to reduce time to market for any analytics based improvement like predictive maintenance, operational excellency, or energy efficiency. Workflows are created visually in the edge streaming creator application. It provides analytical functions and machine learning out of the box, but also allows for inline coding of C or Python code also. The edge streaming manager provides The Edge Streaming Manager provides monitoring, deployment, and automation features for multiple edge streaming analytics environment. It allows to easily overview and then debug, roll back the stream processing workflows in the fields. Grouping deployments and filtering by user defined tags helps to manage very large environments and deployments. The key value of edge streaming analytics will have reducing data at the edge. The aggregate data, that means the aggregate data generated by IoT devices, is generally in proportion to the number of devices, definitely. The scale of these devices is likely to be huge, and so is the quantity of data they generate. Passing all this data to the cloud is inefficient and is unnecessarily expensive in terms of bandwidth and network infrastructure. Analysis and response at the edge, in a sense that some data is useful only at the edge, such as factory control feedback system. In cases such as this, the data is best analyzed and acted upon where it is generated. The time sensitivity, when timely response to data is required, passing data to the cloud for future processing results in unacceptable latency. Edge analytics allows immediate responses to changing conditions. The application side of this edge analytics, we can say one prominent example of edge application is in the use of digitally connected traffic system. A party, for instance, a law enforcement department might want data like camera images, okay, or sensor speeds in real time or before the data has trickled into a data warehouse for consistencies. The CCTV units and other endpoint devices can deliver the timely data through edge analytics. This is one of the applications of edge analytics. The distributed analytics system for the IoT. It spreads the data analysis workloads over multiple nodes in a cluster of servers rather than asking a single node to tackle a very big problem. The same algorithms run across each node, processing a subset of the data. And when the processing concludes, the data sets are aggregated and then brought together in order to generate the collective insights. So we have edge location sensors and edge processing, processing platforms for fog, that is fog processing, and then data centers. Network analytics is the next topic, wherein it is some other kind of analytics that is extremely important in managing IoT systems. In a sense that IoT systems, which are network based analytics, unlike the data analytics systems, which we discussed in our previous slides, like edge analytics, distributed analytics, that are concerned with finding patterns in the data which are generated by the endpoints. Network analytics, on the other hand, is concerned with discovering patterns in the communication flows from a network traffic perspective. Network analytics has the power to analyze the details of communication patterns made by the protocols and correlate this across the network. So, this is very much clear that from this one, this is very much interested, this network analytics are very much interested in discovering the pattern, whereas the previous two types of analytics were concerned with the data analytics that we have discussed, but this one is very much interested in discovering the patterns in the data generated by the endpoints. So network analytics, data analysis systems, network analytics has the power to analyze the details of communication patterns made by the protocols and correlate this across the network. It quickly identifies anomalies in a sense. So network analytics will quickly analyze or identifies the anomalies that suggest network problems due to suboptimal paths, intrusive malware, or excessive congestion. Next thing is that it will figure field area network that shows traffic analytics performed on aggregation router in a smart grid. Flexible net flow architecture. It is a flow technology developed by Cisco Systems that is widely deployed all over the world. The key advantages of this flexible net flow architecture are in the name itself, it is there. The flexibility, flexible net flow architecture. Flexibility is the key advantage of FNF. Flexibility, scalability, aggregation of flow data, ability to monitor a wide range of packet information and procedure, new information about the network behavior. Another advantage is that it has the enhanced network anomaly and security detection. It is user configurable flow, provides user configurable flow information for performing customized traffic identification and ability to focus and monitor specific network behavior. It has convergence of multiple accounting technologies into one accounting mechanism. Like Flexible NetFlow FNF and IETF RFSC 5101 RFSC 5102 are the examples of the protocols that are widely used for this network. So I can summarize whatever we have whatever the deliverables has been done from my part. I can summarize that the IoT systems are producing vast volumes of data, far more than ever before. So because of this, the business value of IoT is not just in the ability to connect the devices, but it comes from understanding the data these devices create. A new form of data management thus arose. It is called as IoT data analytics. Traditionally, data management was performed by relational databases, which cared for well structured data in the tables, where the relationships between the tables and the data structures were well understood and could be easily accessed through SQL. However, the majority of data generated by IoT devices is unstructured, as we discussed. As the IoT data is collected over time, it becomes big data and requires special handling in order to reveal the patterns within the lake of data. To unlock the value of data, special algorithms that perform machine learning are required to process the data and find solutions. Different types of machine learning can be used for specific purposes, including supervised, unsupervised, and neural networks. Processing of aggregate IoT data happens in the cloud or at the data center and is performed by the big data analytics. Such as NoSQL, Hadoop, and then MPP. These systems are specifically designed to deal with the vast volume of data, the velocity and the variety of data generated by IoT systems. Over the time, the streaming edge analytics systems have been developed not only to filter and reduce the data generated by IoT devices, but also to allow like a near real-time response to the IoT devices as close to the edge of the network as possible. Finally, a different form of analytics such as network analytics we discussed. This network analytics does not look at the content of the data, but rather it is used to discover the patterns in the communications behavior of the network, helping to identify the security levels, vulnerabilities, and plan network evolution and better understand and behavior of the various network elements. So we can say that network analytics comes in many shapes and forms, and each of them have the key role in the world of IoT and helps to define the true value that comes from these things. Thank you.
Thank you for the briefing session, ma'am. We have a question from a participant.
Yeah.
What is the use of HDFS file system?
HDFS file system is used for monitoring and processing voluminous data in a faster way. If HDFS system wouldn't be there, then processing of such a kind of voluminous data was a big question mark. It need to be processed, plus it need to be result has to be obtained very quickly. These two things can done with HDFS only, because HDFS is typically used for big data analytics. Whenever the size of the data grows, or the relational, that is what I concluded, the relational database management was not so very well suited in order to handle the data coming from IoT. We are talking with respect to IoT, right? So when millions and trillions of devices are connected to the network, obviously the data generated by them will also be more. In order to handle that in a fast and a better way, HDFS will be used.
Okay, ma'am. Thank you. Thank you for your precious time. Looking forward for further collaboration with you, ma'am. Thank you so much.
Thank you so much, ma'am. Same here. Thank
I
you,
thank
sir.
all the audience. Yes, ma'am.
Yeah, I would like to thank once again to Dr. Rajendra sir, providing an opportunity, and the team which is working towards this one from past 1 week or so. Yes, and at the same time, I would like to express my regards to the management and the principal of GSSSIETW. Thank you so much, one and all. Thanks the participants for their time and their patience hearing.
Thank you, ma'am. Thank you again. I thank all the audience for taking part in today's session. We will be having a session on IoT physical devices and endpoints by Professor Harshita K, Department of CSE, VVCE, tomorrow at 3 p.m. So meet you all tomorrow. Thank you.